Our target in this question is to find the perimeter of the shaded portion. This is the shaded portion, and we want to find the perimeter of the shaded portion. This video is very interesting. Believe me, if you watch it to the end, you will learn a lot from it. So endeavor to watch this video to the end. Before we continue, let us understand the question properly. So this is the question. It says, the figure below shows two circles with centers A and B and radiuses 5 and 8 centimeter. If point D is a tangent, find the perimeter of the shaded region. So we are looking for the perimeter of this shaded region, this region DEC. The shaded region, that is what we are looking for. I know you want to solve this problem and put your answer in the comment section. Feel free to do so. However, there is another question at the end of this video that is also interesting, and that is the question I want you to solve. And when you do that, put your answer in the comment section. But in the meantime, feel free to drop an answer to this if you want to. Now, let us look at this question properly and solve it. This video is a bit long, but it is very interesting, so endeavor to watch to the end. Now, we are given two circles. The centers are A and B. The radius of the big circle is 8. The radius of the small circle is 5. So definitely, this length here, AD, will also be 5 because it's also a radius of the small circle. And this length BE is equally 8 because it's also a radius of the big circle. Now, we are looking to get the perimeter of this shaded region. The shaded region, or rather the perimeter, is the total side bounding this shaded region. It means the length DE, the length of the arc EC, and the length of the bigger arc DC constitutes the perimeter of the shaded region. So once we find each of these sides, we can add them together to get the answer. In other words, the perimeter of the shaded region is equal to DE plus arc DC, this arc here, plus arc EC, this arc here. Now we have demystified the problem. We now know what we are looking for. We just need to get the length DE, arc DC, and arc EC. Now we know what we're looking for. Let's take it one after the other. Let's start with the length DE. How do we get this length DE? Remember, E is a point along this straight line of BD. E is a point on it, and BE is 8. So if we know the entire length BD and we take away BE, which is 8, we are definitely going to get DE. So the first things first is to find the entire length BD. Now look at this again. BD is a side of a right-angled triangle. Let's extract the triangle to make things easy and clearer. This is the triangle ABD. Let's look for the length BD. We know that from here, AB will be equal to 5 plus 8, that is 13. AD is 5. Let's put the values here. We have 5 and 13. Now we know two sides of a right angle triangle. It is obviously very easy to get the third side of the triangle, BD, simply by using Pythagoras theorem. So according to Pythagoras theorem, BD squared will be equal to 13 squared minus 5 squared. The hypotenuse squared minus 5 squared. 13 squared is 169 minus 5 squared is 25. I know some persons do not know that Pythagoras theorem, or from Pythagoras theorem, this is not the usual arrangement. If you know how to solve using Pythagoras theorem, solve this problem, you will find out that you will come around these figures and you will realize that this is correct. So it is not time for quarrel yet. Just solve it the way you normally want to solve it. And if you don't understand how to solve Pythagoras theorem, you can go into my page, search for Pythagoras theorem. I've done several videos on it and learn about it. But in the meantime, let's continue. BD squared is equal to 169 minus 25 gives us 144. To obtain BD, we take the square root of 144. So that BD is equal to square root 144 and BD will be equal to 12. I know someone is asking, why didn't we put plus or minus here? We are looking for the length BD. Length is never a negative number. Length is always a positive number. So we do not require a negative solution here. So we've discarded it and we took only the positive solution, which is 12. Moving on, we have BD as 12. We know BE is 8. So definitely DE will be the difference between BD and BE. So DE will be equal to 12 minus BE. Of course, BE is 8. So that DE will be 12 minus 8, and that is 4. Now we have obtained DE. Let's move to the next arc DC, which is this arc in this small circle DC. Let's bring it out to make it clearer. This is the small circle. This is point A, the center of the circle. This is 5, and this is the length of the arc we are looking for, DC. In mathematics, there is a formula for solving the length of an arc, and that formula requires that we know the angle sustained by the arc at this point A. We need to know this angle to use that formula, but we don't know the angle. So it means the next thing we want to do is to find the angle at this point A, which is the angle here. So let's call that angle theta. This is a right angled triangle with two sides and an unknown angle. We can get this angle using trigonometric ratio. The hypotenuse is given, the adjacent is given. To obtain the angle, we need to know the relationship between the adjacent and the hypotenuse, and the relationship is simply cos theta. So in triangle ABD, cos theta is equals to 5 over 13 adjacent over hypotenuse. If you don't know what trigonometric ratio is, search my page. I have done videos on trigonometric ratio. Learn about them there. For now, let's move on. To obtain theta, we're going to take the cos inverse of the right hand side. So that theta is equals to arc cos 5 all over 13. If you punch in this into your calculator, you will obtain theta as 67.4 degrees. It means the angle here is 67.4 degrees. Now that we've known the angle, obtaining the arc DC becomes very simple. Let's move to the next page. So this is the circle, this is the angle 67.4 degrees. We have to find the length of the arc DC. We've obtained DE already as 4. Mathematically, the arc DC is given by the formula theta over 360 times 2 pi r, where theta is the angle sustained at the center. So to obtain the arc DC, we simply substitute 67.4 in the place of theta, all over 360 times 2 times pi. Pi is 3.142 times r. R is 5. If we put this value into the calculator, you obtain the arc DC to be equal to 5.88. Now we've obtained arc DC. Let's move to the last one, arc EC, which is the arc, this small arc sustained in this big circle. Let's bring it out again. This is the big circle. We are looking for the arc EC. To find the arc EC, we also need to use this formula, which means we also need to know the angle at point B, this angle here, which is this angle in this triangle. Remember, this is a triangle. We need to know this angle here. Looking at this triangle, this is 90 degrees. We know that already from the beginning because this is a tangent. D is a tangent. We are told in the question that D is a tangent. And the angle between the line, a tangent to a circle, and the radius of the circle is always 90 degrees. So this is 90 and this is 67.4. The sum of angles in a triangle is 180. So definitely we can get angle B by subtracting 67.4 plus 90 degrees from 180. So again, in triangle ABD, angle B, which is the angle here, is equal to 180 minus 90 plus 22.6. And that gives us angle B to be equal to 22.6 degrees. Sorry, this is not 22.6, this should be 67.4. 67.4, sorry. So 90 plus 67.4 minus 180 will give us 22.6. So the angle here is 22.6, which means the angle here is also 22.6. Now that we've got the angle B as 22.6, we can easily find the arc EC using the same formula. Arc EC is equals to theta over 360 times 2 pi r. Our theta is 22.6. Let's substitute it. Arc EC becomes 22.6 over 360 times 2 times 3.142 for pi times r, 8. If we put this value into the calculator, arc EC will give us 3.16. So we have successfully obtained DE, arc DC, and arc EC. Let's move to the next page and complete the solution. Perimeter of the shaded region is DE plus this plus this. These are the values. So we simply add up. The perimeter of the shaded portion becomes 4 plus 5.88 plus 3.16. And that gives us our answer as 13 centimeter. There are some fractions in front, but to the nearest whole number, the answer is 13 centimeter. You can see that it is a very, very interesting question. And if you have watched to this point, you must have learned something and you must have enjoyed this video as well. If you did, then here is a very simple one for you to do as well. In this same question, what is the area of the shaded portion? We just solved for the perimeter of the shaded portion. It is now for you to solve for the area of the shaded portion and put your answer in the comment section. I will be there waiting for you. Thank you for watching this video. There is a link in the description of this video and in the comment section for my YouTube page. Do well to subscribe to my YouTube channel. Once again, thank you for watching this video and see you in the next video.